Okay. So here's the spacer we're talking about. So we have these two locating pins. There's corresponding holes in the handle. Focus. And some 3/8 long, 1/8 inch thick or diameter dowel pins that locate, and they got to be pretty tight because they also add weight. And if they're in there and they're not tight, they will rattle around and they won't sound all goody goody. Also, the pivot hole's got to be pretty accurate. All that's kind of fine. That's honestly the easy part. I'll dial in the tolerances when we get to the mill, but basically we're holding it from either side, and something's happening where mid-cut, or maybe even before it's being cut while it's clamping, it's just kicking up. So we gotta work on the cam for that. I'm gonna try two things. I'm gonna lower cutting forces. So I think it's happening when I'm roughing out or I'm decking off the top. I'm kind of facing it with a 1/4 inch in mill. I'm gonna see, maybe I do that 2 passes if I can get a little bit less cutting forces out of it. Second thing, the way we're doing it, we're cutting it out of our handle material stock, which is just a kind of bar of titanium. So we're making 8 spacers out of this, cutting it all in one. The last thing I did, which I didn't really get to test well, because I was doing them 4 and 4 and then clamping them all together, but I think that was not working. So I'm gonna do it for real this time. I'm gonna cut them out individually so that all of the clamps have only one variable. They're only clamping on one spacer. If they're clamping on all 4 at once, it kind of gets a little bit weird. So we just finished our run here. Here's our lovely pallet, and this is where we do the spacers. So this is op 1. Cut them all out. You'll see in a second, and they go into these Uniforce clamps. And like I said, I'm going to do each one individual. So boop, 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 boop. And then you also get to see, this is our op 2 for the gaboons. We hold them in from the bottom. These 832 screws, got them countersunk in. And there's we hold them through those tapped holes for the weight system. And then op 1 is just pit bulls. That's pit bull. It's a Mighty Bite product for anyone that doesn't know. If you've ever run a mill, this should look kind of familiar, kind of like Fanuc. It's a little bit different than Fanuc, but I kind of dig it. Gaboon spacer op 1. Send it. So for anyone wondering, this is a 1/4 inch bull nose. It's a Harvey tool. They're titanium 5 fluid, I think. Probably 5 fluid. And we're adaptive roughing with a pretty aggressive flip path. It's like 15 or 20 thou radial load and lots of surface footage. So we can take it because it's a stubby tool and it's not a lot of depth of cut. So it's kind of our theory. It's been working out pretty well for us. So most of the time, I feel a little bit more cautious about running a brand new program, but since I've already proven the whole program out on the house, and I've already done all of the cooling changes to the dial, this is just a technically new program. I'm less worried about it. I know where they're going. I haven't really changed anything. I did add something on too. We'll run that a little slower, but first time is not very possible. Notice I am tech drilling, which is a good or bad habit of mine. I've just broken way too many drills. So now I tech drill almost everything. Since I don't have true coolant or true spindle coolant, it keeps the heat down, keeps the evaporation up. I can probably be a little bit more aggressive with this tool path. I'll get from film, but I don't want to risk it. I heard it. I don't even know what happened. Huh. Oh, it's slotting. I thought might happen. Here's our culprit. So this... This slot should leave like 15 or 20 thou, but you can see that's actually peeling over into the clamp. So that's no bueno. We gotta fix that. Okay, so I fixed, or I think I fixed it. So I took this where it's slotting out. Like this. Nope. Okay. And I just brought it back a little bit. I also changed our hole dimensions a little bit to make them hopefully a little bit more right. So I'll just watch that. I'm just gonna skip to the good part. Okay. Yeah. So this is the idea. We cut all 8 out, but we just leave a little tab that you can break off, and then you'll load them individually into Op2. All right, so now we're on Op2. So this is where I think I was going wrong last time. See, I'm facing it off. I was taking it mostly in one pass, leaving just a couple thou. And now I'm leaving 50 thou, and then coming back in and leaving 20 thou, and then finishing that off with a different tool path. So hopefully this works. We'll see. Alrighty. I'm gonna wash them off, and then we'll go measure them and see how they turned out. Okay. Let's check on these guys. Okay. I'm not seeing taper, however, they are way oversized. Which may be a programming error, I'm not sure yet. The taper's gone. Okay. So, I'm gonna go fix the oversize, but then that's a problem solved, looks like. All right, so turns out the tool length was slightly off, I'm not sure why. It's about 1.5 thou off, which is pretty significant. I might have measured that tool when the machine was cold, and it's been a whole day of running everything. Now it's warmed up. Possible. That explains a little bit. The program, I was compensating for something on the Haas, probably the taper, and I was leaving an extra 2 thou. So that's another little bit. So 3.5 thou. We were about 5 thou off. So still something a little bit weird. I'm going to throw in a spring pass and see if that does anything. If not, I'll comp it down just a little bit in software. But that solved our problem. So we got rid of the taper. That's all there is to it. Now you get to look at real fun spacers. You know. Let's show out. And these end up in our gaboons. Make all sorts of fun flipping. Silly way. Okay. Thanks everybody. See you in the next video.